Yeah, so the name thing, I won't ask everyone the question, but Python, the programming language, did not come from the snake directly, but was named after Monty Python. And so, being massively egotistical, I decided to take the other half of this like incredibly profound piece of technology and build a side project. Um, Although I do have to say, I spoke to Guido, the creator of Python, length about this last year, and he seemed broadly keen on the idea and mentioned how they had spent years trying to do something similar with CPython itself inside Google, and it had never worked. So that was good validation that this was a good idea. So we've heard lots about sandboxes today and how great they are. They are great, most of all, for infrastructure providers who get to sell you sandboxes. Sorry, Cloudflare. There are some available here. They are arguably perhaps less great for individual developers who want to save money, or for enterprises for whom going and just signing up and using Cloudflare's sandboxes or any of the other sandboxing providers is not trivial. And they're also a pain for developers who want to just get something working out the box and don't want to have to go and sign up for some service. And so we've built Monty, which is a minimal, secure Python interpreter written from scratch in Rust for use by AI. So the idea here is that instead of needing to go and have, let me first talk about like why this stuff matters. I think we've already heard a bit today about like why sandboxes matter, but I think so I should have had a slide with a picture of this, but I didn't get around to building it because I was trying to get my demo to work. There is a continuum from, and I think someone mentioned this earlier a bit, from at one end, basically tool calling the way that LLMs normally interact with the outside world by basically returning JSON and saying, call this tool and return some value. Then the other end of the spectrum, we have like full computer use. The LLM goes and moves your cursor around and types on your keyboard. And probably more realistically, the kind of step immediately before that, Claude Code, where we give it full access to our terminal. It can view all of our environment variables, do crazy, terrifying shit, but also be incredibly productive. And my argument is that there's then an enormous gulf from there to tool calling, which is like very, very restrictive and somewhat safe, but not actually as expressive or as powerful as models can be. And so, thank you very much, in particular, to Cloudflare who wrote this, and my friend Sonal at Cloudflare who wrote this code mode piece, which is arguing for the idea that we can basically replace that tool calling with some minimal sandbox. Obviously, they're saying you should use their sandbox. Also, Anthropic, David's just got here, so thank you, Anthropic, for writing two pieces which inspired me on this. In fact, the real inspiration for Monty, sorry, David, I'm going to slightly shame Anthropic on this. I spoke to numerous different people in Anthropic. Anthropic is incredibly secretive, so no one will tell you what they're doing. But each of them independently talked to me about type safety in Python as relevant for if you're tying together tools with a sandbox. And after the fourth person that Anthropic had independently asked me about this, I was like, they're going to go and do something in this space, and started thinking about it. And then sure enough, a couple of weeks later, these two articles came out where they're talking about this idea of programmatic tool calling, or where you could basically use code execution to make MCP servers more efficient. And so we went and built Monty. Oh, shit. It was up before, wasn't it? I mean, I haven't done anything. It's on screen. I mean, I can talk, but it's not going to be much of a demo. There we are. Okay, well, fingers crossed. We'll keep going. So what is Monty? Monty is a complete rewrite of Python from scratch in Rust. The only existing piece of infrastructure we kind of use is the AST parser of Rough. So instead of having to go and take pure Python text and turn that into some structure, we use the thing that already exists in Rough, which in turn is inspired by the one from Rust Python. So there's like that bit we get given. Everything else we implemented from scratch. So it's like 30, I think now 40,000 lines of Rust. As you can imagine, enormously accelerated by being able to have an LLM do this. This is the kind of task that LLMs love for kind of 4 reasons, which I'll just go through really quickly. One, they understand the internals of what needs to happen, what a heap is, how a bytecode interpreter works in their soul, in the way that most of us would have to go and research how that works. They just know it. 2, they know the public interface. What's the like signature of the filter function in Python? You don't have to tell it that or explain it. It already knows it. 3rd, the unit test is really easy. You can just go test it against CPython and see if it works. And fourth, you don't have to bike shed about what the signature is of most of the stuff. You don't have to discuss what the error message is going to be if you try and add an int to a string. You just say we're going to copy Python for all of that stuff. And there are a number of other projects where those same 4 rules apply, and where LLMs accelerate development most. Well, I won't go into them now. So fundamentally, Monty has no way of accessing the outside world. It can't read files, it can't read environment variables, it can't do networking. So how does it do useful stuff? We allow it to basically call back to functions on the host. So it effectively returns and says, call this particular tool. But we don't do traditional callbacks where you pass in function pointers and then call those functions. Instead, the runtime returns to the host context saying, call this particular function. Here are the arguments and keyword arguments. And at that point, we allow you to go and snapshot the interpreter at that state, give you back bytes, go put that in a database. So if you have a tool that's going to go and take minutes or hours, you don't need the parent process running, waiting for the result. You can go and dispatch that function or that tool, and then resume much later. We effectively have that same callback system for file reading, So instead of actually reading real files on your file system, it basically returns and says, please read text on this particular file. And you can choose to say yes. And we obviously have some infrastructure for giving you like in-memory files, but it never gets access to the real file system unless you basically go and implement your own code to do that dangerous stuff. Startup time, because it's running in the same process, is about 1 microsecond. That's 1 microsecond. So mostly when you look at sandboxes, I haven't tried Cloudflare's one, but Daytona, for example, make an enormous deal about being very fast. Startup time there is about 1 second for a cold sandbox. So we're looking at 6 orders of magnitude faster than maybe 5 if you're lucky, than existing sandboxing solutions. And same if we're calling back to the host. So even if you're doing things very quickly in a hosted sandbox somewhere, you've got at the very least the speed of light going back from that sandbox to your machine. Here it's within the same process, so we're looking at, I say one microsecond. Because it's all Rust, you can run it anywhere where you can run Rust. So we have a Python package which wraps Monty and lets you call it from Python. We also have a JavaScript package, and you can call it directly from Rust, and we might add others in the future. But the main point here is you don't need an extra sandbox. You don't need to go and wrap this in Docker. You can go and run it in your process, and it's safe. I mean, it's early, so I'm not going to go and say it's like production grade, but the principle is it's completely safe. A lot of people have already gone and tried to break it. They have found places where it will panic, places where it will Stack Overflow, places where it will No one has found ways of it actually accessing anything on the host because the code just doesn't exist. The main point to say here is this is not trying to be another Python interpreter. There is a graveyard full of people who've tried to build Python interpreters. They have all failed because to be genuinely useful as an alternative to CPython, you need like 5 nines of compatibility with CPython. This is not to take your legacy shitty Python application and run it with our thing and it would be better. It is very specifically for AIs to write code that you can run safely. I don't know how I'm doing on time. I'm just going to keep waffling and get told to shut up at some point. This is a hello world example. Nothing very interesting happening here. We're gonna print hello world. Here we're calling Monty from the Python library. So if I go and run it, hooray! We got back the result. That was it actually running. So you see the boot up time. Few things to note. We can pass inputs. We haven't got any functions here, but if we registered functions, we could do that too. I'm now going to go on to a slightly longer demo. So this is all very well, but what does it look like to actually go and take this thing and hook it up to an LLM? So we, as a company, have Pydantic AI, which is our agent framework. So in the same space as LangChain, but less shit is the simplest way of describing it. Sorry for I'm not supposed to say things like that, I know, but I'm in a hurry. Here we have our agent. We're using Anthropic through our gateway, but instead of registering, well, I suppose if we do this, we're now registering some tools directly with the agent. So we're using standard tool calling, and the tools we're registering here are getLat_long, which takes some location and returns latitude and longitude. get temp, which is going to take that long and return you the temperature in that place, and a get description. Now you can see how you can tie those three functions together to get back a result. But if we go and run this with standard execution, what you will see, you'll see the logfire trace. Logfire is our observability platform, which I will very quickly use to demo this. I'm not going to go into it in masses of detail, but I think you can kind of see, or maybe the simplest way actually is to look at it here. So you can see, sorry, let me go into that span. And so you can see here what happened. We started off with a system prompt, with the input. The output was, why am I not seeing? Yeah, so you see here we called these the get that long tool 3 times in parallel. Claude was clever enough to realize it could call these 3 tools in parallel. Then we go back to the LLM, and then it goes and makes the second tool call. In this case, we're actually kind of lucky because we get to do it relatively quickly. We get to go and run those other tools in parallel. So this example won't be that much faster with code mode, but hopefully it will kind of demonstrate the idea, and then I'll go and show you a more powerful example next. So what we can do is, instead of registering this tool set, we're going to register this code execution tool set instead. So that's going to take the tool set, and what Pydantic AI is going to do is take care of wrapping that in code execution. So what we're actually going to do is expose one tool to the LLM, which is called run code, and it's going to have a signature which says these are the tools, these are the functions you can call from that code. So if I go and run that, and as I say, this isn't going to be that much more efficient or cheaper or anything, but the next example will show the power. So if I open this, it's thinking about it hard. You can see it's running and it has now finished. So it was a tiny bit faster in this case because it's a very simple example. But if we look at what it's done, it's the tool it calls was the run code tool, and you see it wrote a bunch of Python code to call those tools. So you see it internally calling get lat long, it's using async.io gather to do those things in parallel, and ultimately returning some result. And so we've gone in this very simple case from 3 calls to the LLM down to 2. In more complex cases, you can go from like tens or hundreds of calls to the LLM down to 2 or 3 if you're lucky. And one of the powerful things is, because we have this intermediate code, we can go and debug very easily what it is that the LLM gets wrong if it makes a mistake. One thing I forgot to mention is we have TY, the new type checker from Astral, built in to Monty. So before it runs the code, it goes and runs type checking over it. And so the LLM will get back feedback if it's doing something wrong, if there's a typing issue, which makes it, again, improves the reliability a lot. It's worth just quickly looking at what the run tool code signature looks like. So you see we have a bunch of instructions on what kind of Python code to run, but then in particular we have the Python signatures of the tools it's allowed to call. And it goes on. Let me move on to a slightly more. How am I doing on time? Oh God! Now I'm about to get to the demo. Okay, so we're going to have to speed our way through this demo somewhat. So one thing you have to understand about the big model providers is they have a deeply developed sense of irony. So they have made their billions out of scraping the internet for knowledge and then turning them into LLMs. But because they have this deeply developed sense of irony, they've made it incredibly hard for you to scrape their websites. In particular, they won't even give you a programmatic response for their list of prices. So one of the things we do in Logfire, you can see here, we have the prices of each individual LLM call that we make. And so we have to go and basically read the websites of all the big LLM companies and get back their prices. Until now, that's been done manually. I'm using Anthropic in this example, but I'll say I'm using it because OpenAI's one is even more egregious. I think they were even using the Cloudflare's don't let us scrape your website tool at one point to stop them, stop us from going and scraping their websites. So I don't know how much time I'm going to have on this example, but the idea here is that we're doing something, we're moving along that continuum I talked about, from pure tool calling into kind of computer use. Because the tools we're registering here are playwrights to go and load a website into the kind of Monty runtime, and then we're even able to go and take Beautiful Soup and expose a data class, which is represents a tag in Beautiful Soup, then a bunch of functions, these will soon be able to be methods on that data class. So we can basically construct arbitrarily complex Python interfaces to expose to this LLM, so we can give it a curated context in which to go and execute. And this allows it to go and do effectively arbitrary computer use, but you need to go and design that context, or we need to give you tools to build that context. You can't just say, oh, here's a full Linux machine, you can go and run everything you want, or here's a full Python interpreter, or go install an arbitrary library. You need to be disciplined about what you add. But actually, in many cases, that's powerful because we don't want our agent for getting GenAI prices to be able to go and do arbitrary stuff. We want it to do specific things. If you think about the fairies example earlier, it's cool it can run Claude code, but probably in many cases, the things we want those fairies to be able to do are relatively constrained, and being able to give it this kind of controlled tool calling or controlled code execution might be more powerful. So I know I don't have very much time, but I'm going to load up a full example here. So this is the full span from it going and getting prices from OpenAI, from Anthropic's website, and it's probably easiest just to look at the full exchange with the LLM. You see it gets a bunch of instructions on what to do. It gets the URL it's going to go and visit. You see it writes some code to go and get that data and then process it with beautiful soup. So in this particular case, you just couldn't use tool calling. The HTML you get back from loading this page is bigger than the context window of an Anthropic model. So you have to go and do some processing. Pure tool calling would never work. And yada, yada, yada. It writes a bunch of code. Some of it is explorative. And then at the end, it ends up with some like valid code to go and basically effectively extract the prices. What's cool here is there's a second model running as a sub agent, which again is available as a tool. So the code is able to call sub models to, in this case, do some of the extraction tasks. One of the really neat things is that the response I have here is not just the prices of the models and some summary of what's going on, but we said, please also return the optimal Python code to use for this task next time. And so when we rerun that same task, it doesn't need to go and do the full exploration of like, how do I do this thing? It doesn't need to reinvent the wheel. What we can do is, you see here where we have existing code true. It's not that much faster in this particular case, but in many cases it will be much faster. You see it's much faster once it's already got basically how it did it last time. And this will be incredibly useful for lots of agents which are going to be doing repetitive tasks, which will be very common in lots of scenarios. I think I'm probably getting towards time, so I don't know if I've got space for any questions, but thank you very much.